So in this video, we'll look at a desmosification. I guess that's a word of the math that we've done in class. We've reviewed the idea of the slope of the secant line. We've done the point slope form of a line. And this then would be how you would write that equation of the secant line in point slope form. And we're going to use our capabilities in Desmos to add slider bars for some of the points and then use this demo to demonstrate how the secant line and the tangent line are related. Okay, so let's go ahead and dig in. Let's maybe look at a specific function, and let's look at the x cubed function, for example. Let's create a point C comma f of C, add a slider bar for C, and then label that point. So here is the point 1, 1, or you can move that point around. Let's go ahead and create a point x comma f of x. Okay, and we'll add a slider bar for x. Okay, and then we can have the point x moving, and let's create a label for that one. Okay, so what we're going to need is the slope of the secant line here, and then we can go ahead and put that slope of the secant line into the equation of the secant line. So let's go ahead and do that now. That would be f of c, the equation of the secant line. That's the y value of the point, and you add on the slope of the secant line, which is the change in the y values, divided by the change in the x values, and then we multiply that by, times x minus c. Okay. So, parentheses. There we go, there's my parentheses. Let's change the color of that. If you hold down on this, we can make that line blue, for example. So there we have it. Here is the secant line, and that secant line changes for various values. And I might need to, let's copy and paste this part of it and add a new so we can see what the slope of that secant line is. So there's our line in blue, and if we change where this purple point Q getting closer and closer, we can see that the secant line slope is changing. Okay, so there we have the ability to compute the slopes of our secant lines. We have the ability to graph our secant lines. And the only thing that we haven't talked about is putting the tangent line on there. So before we do that, let's just show how you can also move the point C, and you can see that the secant line is the line between those 2 points, blue and purple there. And as the purple point gets closer and closer and closer, that secant line is changing until eventually the secant line starts to approach this line that we haven't shown on the graph called the tangent line. So let's go ahead and bring in the tangent line now. And I'll have to say a lot more about this, but I'm just going to write down the formula for it so that you can see. I'm going to put a little vertical tick mark there. And we need to, of course, discuss this a lot more over the coming days. Let's make that secant line, the tangent line, let's make that black. Okay, so here we have the tangent line at that blue point. Okay, the blue point is adjusted by moving the C value. So we've got that tangent line there. It's a tangent line because the black curve is matches really well with the red function the closer you get to that specific point there. And then as we zoom out, we can see the secant line again. And as the 2 points get closer and closer, let's move the purple dot closer to the blue, and the secant lines we'll see starts to get closer and closer and closer to the tangent line. And so what we're going to have to focus on in the next couple of days is this number 5.47 here. And the closer the x value gets, we're going to see what happens to that 5.08, 5.47 number. Okay, if you move, the same picture is going to happen if you move your point of interest, right? So now we have a new tangent line, the black curve at this new point matches really well with the function. It's a line that matches the function at that one point. If we zoom back out, we can see that the light blue line is the secant line, and as the values of x get closer and closer, we will see the secant lines in blue get closer and closer to this thing called the tangent line. Delving more into the details of this demo is going to be the subject of calculus. How are the secant lines and the tangent lines related to each other? We need to begin working on figuring out what is the slope of the tangent line by using the secant lines, and we'll discuss that concept using a limit in the following days. So thanks for tuning in. We'll see you next time.